Right, IPv6 and routing. IPv6 and routing. So we got various routing protocols: RIP, EIGRP, and Ospf, and then the path vector protocol BGP. All this supports IPv6. Even MPLS supports IPv6. Because you don't know what is MPLS, I'm not touching that area. But when we come to CCI, we'll definitely learn IPv6 with MPLS. Now, the basic fundamentals about these routing protocols are same. Like RIP is again a distance vector protocol in both IPv6 as well as in IPv4. RIP NG, next generation, or it is also called as IPv6 RIP. You can call it as IPv6 RIP or RIP NG. EIGRP, we call it as IPv6 EIGRP. IPv6 Ospf. And BGP. BGP is IPv6 version of BGP. There is no special version actually. It is simply BGP, but we have something called IPv6 address family. All right. So this is what. Okay, this is another one, version 3. Ospf is IPv6 version. Ospf is called as version 3 Ospf. IP version 4, Ospf version 2. So these are the names we call IPv6 RIP. There is no version 1 and version 2 in RIP. There is only one version, a classless version of RIP. There is no classful, classless behavior in IPv6. There is no subnetting as we do in IPv4. We don't have that type of subnetting, like borrowing some bits. We don't have that type of subnetting here. Not needed because you got 128 bit size address space. EIGRP, it's same like IPv4, but one difference is we need to provide a router ID. We need to provide a router ID for EIGRP to be activated, and the other things are same. Autonomous system number we need to give. And one more difference is we need to say no shutdown command, no shut. We need to say no shutdown command under EIGRP mode. Under EIGRP configuration mode, we need to say a word called no shutdown. And all the network related commands come under EIGRP interfaces. So we don't advertise by saying network command in EIGRP. We go under the interface and we enable EIGRP on an interface. Now that interface will start advertising the network that is there on that interface. So there is no network command. We don't have any network command. No network command. Other things are same. EIGRP has got 5 metrics: K1, K2, K3, K4. As you learn in IPv4, bandwidth and delay is what by default turned on. Load, reliability, and MTU is off by default. If you want to turn it on, you can turn it on. What about IP version 6 Ospf? This has got no much difference. It's same like IPv4 as we enable IPv6 Ospf. We must make sure that there is a router ID. There must be a router ID. Even in IPv4 there must be a router ID, and router ID is picked automatically. Even in IPv with IP version 6 Ospf, which is version 3, even in this we can provide router ID statically. If you don't provide, it will pick from a interface. It will pick from the router. So it should be, the router ID should be a 32-bit address. A router ID in both IPv6 EIGRP, IPv6 Ospf. The router ID should be a 32-bit number like an IPv4 address. That IPv4 address is just for router ID. It will not be routed. It's for just identification. So IPv6 uses IPv4 address for identifying the device in the autonomous system or in the area. That's what router ID. And there is no need of saying any no shutdown, and all the configurations go under interface even here. Another thing, even here, when we talk about configuration, even the RIP command, all RIP related commands go under the interface. We do under interface. We need not to do anything on the global configuration mode for RIP. No need to say IPv6 router RIP or something like that. All configuration for RIP goes under the interface. BGP, it's same like IPv4. BGP you enable. The only difference is we will be adding an address family and enabling IPv6 under that address family. So we are going to see these 4 protocols now. I'll take a topology like this. If you want, you can also draw with me. The topology we'll try to keep it simple. Let's take router 1 with some LAN device. So I'll take router 2 and router 3. We'll have router 1, router 2 and router 3, and it's a LAN switch. And then this one we will connect to router 4. Let's say that is a WAN interface. See, we have a serial interface. We have a WAN interface, serial 1/0, and that is connected to router 5. Alright, so to make it more realistic, I can also bring a frame relay into the picture, but not necessary. I don't want to confuse you too much. It's not really needed. If something is really needed, I'll definitely mention. I will not skip those things. So though you can have frame relay in the middle and learn something related to frame relay and IPv6, I'm just skipping it because it's not really necessary. Nowhere it has been deployed. So frame relay you don't see much in the real world. So I want to just have a WAN interface, a serial interface, and we'll have IPv6 here. Now this is the same topology we may be using tomorrow as well. Maybe there may be a slight variation in the design. I may remove 1 or 2 routers, but almost we'll have the same topology. We'll try to have the same topology. Tomorrow in our class, our discussion will be, today we will be finishing with the routing protocols. Tomorrow we will be discussing about the migration strategies. How you can migrate from IPv4 to IPv6. What are the different migration methods we have, like dual stack, like NATPT, like tunneling, like ISA tab, and so on. So we got LAN and WAN mixed in this topology to say that the configuration way, it's the same for both LAN and WAN. Whatever you did in IPv4, the same way you're going to do it for IPv6. There is no much difference. What I mean is, when you talk about Ospf, when you have frame relay cloud in the middle, we don't have a frame relay cloud here because it's not widely used or popularly seen. So I don't want to make the thing more complicated here. So in case if you have frame relay in the middle, and you will have a lot of PVCs. Now in case if you have something like that, that is considered as NBMA network, non-broadcast multi-access. So what you do in IPv4 is we have different options, like 5 network options: non-broadcast multi-access, and then non-broadcast is one, and then point to multi-point is one, and then point to multi-point non-broadcast is one, and then point to point, and then broadcast. There are 5 different NBMA modes. Same 5 modes are even here in IPv6, and how you configure OSPF under interface in IPv4. The same way you also enable IPv6 under interface. Now here, IPv6, everything goes under interface except BGP. Most of the configuration go under interface. You don't use network command to advertise any network. In IPv4, we can do, for OSPF, we can do both the way. You can use network command, or you can go under the interface and enable OSPF. Whereas here, even for RIP and EIGRP, you need to do under interface. RIP, EIGRP, and OSPF, you must enable only from interface. I'll show you those things in some time. But for BGP, it is the same way, network command as you did in IPv4, you will also do it for IPv6. Now this is the topology. Let's quickly do the addressing scheme and then we'll up and running. I would like to keep loopback interface on all the devices. Why? Most of the protocol, the protocol EIGRP, RIP and EIGRP, OSPF and BGP, these three protocol, EIGRP, OSPF and BGP, they need a 32-bit identification number, which can be manually given. It will also pick dynamically, automatically, if you have an IPv4 address on all this router. So just for the router ID sake, I will have a loopback interface on all the router. Loopback interface on all the router with an IPv4 address. I'll just say 1.1.1.1.32. I'm not going to use this for routing purpose. This is just for the router ID sake. Now when I assign the loopback address with this addresses, this will be picked as the router ID for the protocols like EIGRP, OSPF and BGP. Let's do it. Now let me start from router 1. Router 1 configuration, enable config T. I can also use notepad. Only for one router I'll do like this, and for the next router onwards I'll do using notepad. Interface fast Ethernet 0/0. No shut. IPv6 address 2000:ABCD:1/64. Meaning I'm giving the complete 128-bit address statically. I'm not using EUI64. So first half 64-bit is masked, the network portion. And I also want to give the link local address manually. If you want to give manually a link local address, we can give like this, FE80::1 link local. And I also want to give this loopback interface address. As we discussed, it will be used for routing. The routing protocol will use it as a router ID. So I'll say interface loopback 0, IP address 1.1.1.1, 255.255.255.255. All right, we are not going to run any protocol, any IPv6 on this IPv4 address. But I would like to have loopback interface with IPv6 as well. See, you can have IPv4 address as well as IPv6 address on the same interface. You can have. /128. I'm masking it completely. So you can have IPv4 as well as IPv6 on the same interface, which is called dual stack. That won't cause any problem. Now, the reason why I use this one is to show how the routing protocols work. If routing protocol is enabled, this network should be advertised to R2, R3, R4 and R5 for the testing purpose. But why did I give this one? This is for the router ID. So that I need not to manually assign router ID for routing protocols. Okay, so R1 is ready. But very important is this: show IPv6 interface. Sorry, no need to say IPv6 interface. Yeah, you must say show IPv6 interface fast Ethernet 0/0. Now when you type in this command and hit enter, you can see that by default it has joined a link local address called FF02:1:FF0001. The scope of this address is only on that node. If you want routing to be enabled, this is not doing routing job. This multicast address will not help you to do any routing. So for that you need to join another multicast group which supports routing, which is by giving this command IPv6 unicast routing. See, I want to see very clearly. We have only this multicast as for now enabled. This is not enough for you to have routing protocols on this router. If you want to have routing protocol, you need to join FF02::2 here. You need to join that multicast group also. To join that multicast group, the command is IPv6 unicast routing, meaning enable routing for IPv6. That's the command. When I type this command, you can see that I joined the routed group. Now I can enable routing protocols in this router. The first protocol that we will be enabling is RIP. Let me show you how to enable RIP. See, for RIP you no need to say IPv6 router RIP. Not necessary. Need not to type this command in the global configuration mode and go inside. Sorry, if you want to do like this, you should give a name here. I'll give a name like my_RIP. It can be any name. So if you want to really go, you can go like this. So you are inside the RIP router mode. But I'm telling you, it's not necessary. Where do you see network command? There is no network command. You cannot advertise. There is no network command, so you cannot advertise by using network command. If you want to change the administrative distance, only then you come here. Or you want to do you have some distribution list written and you want to filter or allow based on the distribution list, then you do this. Or the maximum path for using the traffic to flow over multiple links, then you can come here. If you want to deal with some Poisson rivers, you might have learned in CCNA about what is Poisson rivers. So if you want to do some changes, you can do here, like redistribution. If you want to cancel split horizon, you want to change the timer, only then you come here. Otherwise there is no business of coming here. So we go straight right to the interface itself. See, on loopback interface also we have an IPv6 address. You remember on loopback interface I gave the IP address like this: 1111:1111::. I think I also gave 1111::1/128. So I want to run RIP both in loopback interface as well as the fast Ethernet interface. So how to enable RIP on this interface? Very simple. IPv6 RIP. And then give a name. What name I gave in the global configuration mode? I said my_RIP. Alright, so give that name here. But you need not to go to global configuration mode, do that and come here. Not necessary. You can come straight to the interface and do this. Because I already went to the global configuration mode and gave that name, I'm using the same name. My_RIP, and then you need to say enable command without fail. Now RIP is enabled already in this interface. What is the proof? I'll show you the proof. Show IPv6 protocol. You can see that there is a RIP protocol, routing protocol called RIP already enabled, and the name of the protocol is my underscore RIP, and the interface that is running this RIP is only loopback 0. And if I want to enable on fast Ethernet, you know the command now what to do. The command is IPv6 RIP, give the same name, my underscore RIP, enable. That's it. Now if you want to go and verify one more time, you can type show IPv6 protocol. Now I see these two interfaces are running RIP. Now the similar ways we are going to configure R2, R3, R4 and R5, but by using a notepad, which will make our configuration a bit faster. Right, our notepad is ready. Enable config t interface loopback 0 IP address 2.2.2.2 255.255.255.255 IPv6 address. The IPv6 address we want is 2222:2222:2/128. And then I also want to enable RIP now itself, so I'll say IPv6 RIP. You can give different name on different router. You need not to have the same name my underscore RIP when you configure RIP on the other routers. If you want to keep the same name for remembrance sake, for the convenience sake, for your convenience, you can do that. You can give that same name my underscore RIP. You can also give some different name, but on the same router, don't use different name for different interface. On the same router, do not use different name for different interface. Then it will become two different RIP process. Now I want to give some okay, I'll say R2 RIP enable. Next is under the interface fast Ethernet 0/0, I'll say no shut IPv6 address 2000:ABCD. That is what we discussed as the network portion, and the host portion is 2/64. I want to give the link local address as well, so I'll say IPv6 address FE80. Always link local address will start with FE80, and you should not put any CIDR notation like /64 or 128. You need to say link local. All right. And what else? You need to enable you need to enable RIP, IPv6 RIP. So I copy the same name. It should be same name on that same router. I pasted it here. Now, one thing I purposefully missed. I don't know whether you remember. I gave one command called IPv6 unicast routing to join the IPv6 routed group, or to join F02::2 multicast group. I am not typing that command IPv6 unicast routing. See what happens. When I paste this command, because I have RIP enabled, I am trying to enable the RIP, it will throw an error. See, when I paste this one without giving that command IPv6 unicast routing, it will throw an error. Copy, paste it. See, when it was trying to paste the IPv6 address, when it was trying to paste the IPv6 for RIP, it says IPv6 routing is not enabled. So if you want IPv6 RIP to be enabled, you need to enable first IPv6 routing. So what is the command? The command is IPv6 unicast routing. Now if I paste that same configuration, I'll not have any error. So let me copy one more time and paste it. See, this time it is not showing any error. Okay, this is because of hyphen. I didn't give hyphen, so let me put the hyphen. Link hyphen local. So it's neat now. Let us verify. The verification command is show IPv6 protocol. We see that RIP is enabled. This is the name given and it is running on this 2 interface. Now, what do you expect? You should expect that 1111:1111 appearing on R2's routing table. Let's verify that. Show IPv6 route. Look at this. Via RIP, it has learned 1111:1111:1/128, which is there on R1's loopback interface. See, 2 hop away. Now it's a second link, and then see the multicast. Sorry, see the link local address that is the one which we assigned on fast Ethernet 00 on R1. This is the link local address we used. We gave for that interface on R1. So what do you understand from here? It is a link local address that is going to discover the neighbor in routing protocol. So your next hop address is not a global unicast address. Your next hop address is a link local address. So link local address is used for neighbor discovery, not only just to discover directly connected router, even by the routing protocol to discover the neighbor, directly connected neighbor. It's the same link local address used. You remember on the first day class we saw about neighbor discovery. So it is also a kind of routing protocol. By using neighbor solicitation, it learns the neighbor address we saw in the previous class. So not only for that link local address is used, link local address is also used to discover neighbor for all the routing protocols. Okay, now R2 is ready. Let's do it on R3 and R4 and R5. On R3, we are going to have loopback interface address with 3.3.3.3, and this is going to be 333:333:3/128. And RIP, I want to give a different name. If you want to give same name, you are most welcome to do that. I'm just changing the name as R3 RIP. Alright, that's all. Okay, let me give that command. In the global configuration mode, I need to type IPv6 unicast routing. So if you type unicast, it will understand. Alright, so this should go with router 3. Okay, see, one more mistake. I didn't change here 3. Okay. Now what will happen if I give 2? What will happen if I give 2? 2 is with whom? Router 2. If I give the same address to router 3, what will happen? You remember DAD, duplicate address detection, that will detect. And R3 won't get this IP address. Let's try that. So on R3, I'm going to enable debug IPv6 neighbor discovery ND. Okay, now I'm going to paste this, and I'm pasting the same IP address that I gave to router 2. Same link local address, same IPv6 unicast address. I am pasting it on router 3. See what happens. See, duplicate address detected, duplicate address detected. So it is not going to pick the address because it has got duplicate address detected. Sending for the DAD. So it should be unique, but R1 is okay. Whatever comes from R1, it is okay. There is no conflict. But whatever coming from R2 will conflict. See, R2's neighbor solicitation. I'm sending the same address what R2 has got. And then only the duplicate address problem starts. Duplicate address. Okay. Let us verify. Show IPv6 interface brief. And see, loopback interface address is taken. But what about... Okay, but this is also taken, but it should have not. When we ping, it will be a problem actually. F 2000 colon ABCD colon 2. Definitely there will be a problem because there are two addresses, duplicate addresses. So anyway, it is detecting that. It has thrown an error. It has thrown a log by saying duplicate address detected. So immediately we have to change that. So I'm going to change it now quickly. 3 here, 3 here, copy. See, equals something, it talks about the error. So even if I don't have a debug enabled, I will get that duplicate address error. Now I have given the right address, I believe. Did I say 3? Yeah, I said 3 and I have changed the address. Now I should not have any problem when I ping 2000 colon ABCD colon 2. Alright, so I also need to see the routes in the routes from the loopback interface of R1 and R2 on router 3. Show IPv6 route. I want to see only RIP routes. So I say RIP. Look at this. It has learned the address of router 2 as well as router 1. So if I ping from here, router 2's loopback interface, ping with my loopback source, it pings, which means that when I'm sourcing from 3333, which means that R2 also knows how to come back to 3333, reach back. R1 also knows how to come back to 333 if this ping will be successful. Right. So R2 knows about 333, that's why it is sending the packet back. R1 also knows, R2 also knows to come back to R3. Now let us enable on R4. On R4 I would like to give 4.4.4.4. colon 444 colon 444 colon 4/128 and RIP 444. This goes with router 4. I think router 4 has got another interface. So let me enable RIP on the serial interface, serial 1/0 no shut IPv6 address 2000 colon AAA colon 4 /64 IPv6 address FE80 colon 4 link local. Let's enable REAP. This is the command for enabling REAP. I use the word R4_REAP enable. Done. Now, REAP is enabled even here. One last router, let me do it manually. On R5, I'll say enable config T IPv6 unicast routing interface loopback 0 IP address 5.5.5.5 255.255.255 IPv6 address. I need to say 5555 colon 5555 colon 555 colon 5 /128 and IPv6 REAP. I'll give the name as R5_REAP. Give a name, enable it. Interface serial 1/0 no shut IPv6 address. So the address is like 2000 colon AAA colon 4 5 /64 and the link local address will be IPv6 address FE80 colon 5 link local. Right, that's all. Now IPv6 is enabled and now I'll enable the REAP. Everything is done. Now if I ping from R5's loopback to any other loopback, I must be able to reach. Show IPv6 route REAP. Look at this. We got updates from 1, 2, 3 and 4. So if I ping now router 1's loopback, I'll ping. If I want to ping router 1's fast Ethernet, I can ping. Router 2's fast Ethernet, I can ping. Router 3's fast Ethernet, I can ping. Router 4's fast Ethernet, I can ping. Obviously, I can ping router 4's serial interface also. And I can also ping the loopback interface behind R3. Right. So we understood that how REAP can be enabled on routers for IPv6. The next protocol we will see is EIGRP. Now, how I'll enable EIGRP? Am I going to cancel all the REAP configuration by saying no REAP? Nothing like that. See, you remember when you don't have this command IPv6 unicast routing command, you are not allowed to provide REAP commands. So if I disable this, it also should disable REAP. Whatever the routing protocol you may have, if you disable this, that routing protocol will be removed. You want to see that? I'll show you. Show IPv6 protocol. No REAP. Gone. Let me show it on R4. Show IPv6 protocol. I'm seeing REAP now. I'm not cancelling REAP. I'm saying simply no IPv6 unicast routing. Now this command will remove all routing protocols. Show IPv6 protocol. Look at this. No REAP. Okay, let us cancel from 3. No IPv6 unicast routing. I'll cancel from 2. No IPv6 protocol. No IPv6 unicast routing. On R1, no IPv6 protocol. No IPv6 unicast routing. Alright, so I have cancelled RIP in every router. So the ping which was happening before, it's not going to happen because there is no route. I'll show you show IPv6 route RIP. Nothing. All gone. Let's enable EIGRP. I'll enable EIGRP on one router and then I'll start using the notepad. You see, I'm going to enable EIGRP on this router. Now we need to do EIGRP configuration both on interface as well as global mode. You see, I'm going to interface loopback 0. Now before that, IPv6 unicast routing must be enabled because I'm going to enable a routing protocol. I cancelled it, so I'm putting it back. And now I'm going to enable EIGRP, interface loopback 0, IPv6, EIGRP, autonomous system number. That's it. Interface fast Ethernet 0/0, type the same number, same autonomous system. But you see here, show IP protocol, I don't see. Sorry, show IPv6. I don't see EIGRP, but I enabled. Show IPv6 EIGRP interfaces, no interfaces. But I enabled on those two interfaces. Then what happened? The reason is we need to get inside this EIGRP, IPv6 EIGRP, IPv6 router, EIGRP, autonomous system number, same number. And if you want to give manually the router ID, you say EIGRP router ID and give the number. But I have already given, a loopback interface is given. So that will be already taken. So not necessary to give. I'm not giving manually. If you want to give, that is the command. All that you need to do here is no shutdown. This is what I was explaining in the beginning. For EIGRP, you need to say no shutdown. Where? Not on the interface. That is very important on the interface, but something new here. We don't say no shutdown under router mode. But for IPv6 EIGRP, you need to say no shutdown under router mode. Now when I say no shutdown, you can see EIGRP up. Previously when I was typing this command, show IPv6 EIGRP interface, it was showing nothing. But now it shows two interfaces. And previously when I was typing show IPv6 protocol, it was showing nothing. But now it shows the entire EIGRP. You see, the EIGRP 10 is running. Autonomous system number is 10. It has got 5K values. It has got the router ID. Same like Ospf, this also picks the router ID dynamically if you don't give. If you don't have a loopback interface with, or if you don't have an IPv4 address on any of the interface in this router, then you must give manually. Right, it is running on this two interface. The other things are same. Whatever you learned for IPv4, it's the same for IPv6. Maximum path for load balancing is 16. By default, it supports 100 hops. You can tune up to 255. By default, the administrative distance is 90, internal, external is 120. There is variance 1. If you want to do unequal cost load balancing, you can change this variance. All those things are same. Right, now let us do it for router 2. I'm going to do it for router 2. Enable, okay, these things are same. Now what I need to do is I need to say IPv6 unicast routing is written already. IPv6 router. EIGRP. I should give the same autonomous system number, you know that, and I'll say no, shut down. And then I'll go under the interfaces and say IPv6 EIGRP 10. Interface fast Ethernet 0/0 IPv6 EIGRP 10. This is the only command. These are the only commands that I need to type on all the routers. So I'll simply copy and paste it on all routers. See how things are easy. I'll go to router 2. I'll paste. I'll go to router 3. I'll paste. It's the same thing. There is no IP address already configured, no? Router 4. Router 4 has got two interface, serial interface, so I need to go under serial interface also. So I'll say interface serial 1/0 IPv6 EIGRP 10. And for router 5 we don't have fast Ethernet, we have only serial interface. So I'll say serial 1/ copying, pasting it on router 5. Done. That's all. EIGRP is enabled. See, it has learned the neighbor. When it learns the neighbor, see through which address it is learning the neighbor. By using the link local address of R4, it has learned router 4 as a neighbor. So it is the link local address used to discover neighbor. Let's go to router 4 and check. See, it's the same link local address. Let us check here. Show IPv6 EIGRP neighbor. I see I got neighbors, but I am seeing router 5's link local address. So because why it is not showing the unicast address, global unicast address? The reason is global unicast address is not used to discover neighbor. It is the link local address. Now you see router 4 is a neighbor for 1, 2, 3 and 5. Now if I go to router 1 and check show IPv6 route EIGRP, I can see all the networks which are not directly connected. I can see 2000 AA, which is between R4 and R5, and if I want to ping R5, I can ping now. So EIGRP is made simple. D means dual, 90 means administrative distance, and this is the composite metric, the FD value, feasible successor value, successor's FD value, and you got it. Now let us go with let's do Ospf quickly. Let me remove the command no IPv6 unicast routing. On all the router I need to type this, so I'll just copy this and use a notepad and paste quickly. Enable config T end. Why need to end? No need to end. So you know what will happen if I paste this command. I will not see. I did that command, no command. Now if I type show IP route, show IPv6 route EIGRP, I don't see any routes now. EIGRP is remote. Show IP protocol, EIGRP is remote. So IPv6. EIGRP is remote. So I'm going to remove EIGRP quickly on all the other routers. 4 removed, 5 removed, 2 done, 3 done. Now I removed EIGRP from every router. The ping that we were doing before will not happen now because there is no EIGRP. Ospf is very simple. For Ospf, you need not to do any global configuration mode. You don't need to do all this. all that you need to do is, there is no shutdown, nothing like that. Only under the interface I need to say IPv6 Ospf, process ID, area ID. It's same like your IPv4. IPv6 Ospf, process ID and the area ID. So this I am going to paste it on router 5. Let's do it. No, before that, what I need to do is I need to type this command IPv6 unicast routing. Okay. Copy and paste it on router 5. That's it. Now OSPF is running. You want to verify that? Show IPv6 OSPF interface brief command. Look at this. OSPF is running on this two interface. IPv6 OSPF. Show IPv6 protocol. You can see that IPv6 version of OSPF is running on this two interface, and it belongs to area 0. So similarly, I'm going to configure on R1, but this time I want to show you something more. Now when I enable a routing protocol, see, you know the power of this command. IPv6 unicast routing will join to a multicast group FF02::2. Show IPv6 interface fast Ethernet 0/0. You see that it is joining this multicast group. Now when I enable OSPF, it joins also along with this multicast, it also joins FF02::5 and 6. Those are the two multicast address for OSPF. So interface loopback 0, IPv6 OSPF process ID, and then area ID. Interface fast Ethernet 0/0. Same command. Now if you see, you can see that it has joined 5 multicast address. It will also join 6 if there will be a DR and BDR election, if it is multi-point. Okay. Now similarly, I'm going to configure all the other routers. Process ID can be different, but only the area should be same on the link to form neighbor. Okay, here it is done. R2 is done. Let me also do it for R3. Okay, R3 is done. R4, yeah, R4 is done. R4 has got one more additional interface serial 1/0. So I'll give the same command here. Now next is see, the router ID is picked up automatically on R5. This is the router ID. OSPF will form neighbor with the link local address, but it will show the neighbor's router ID as a neighbor. So if you see show IPv6 OSPF neighbor, now I can see 1, 3 and 5 are neighbor. So on router 2 I need to paste the command. If I paste, I will also find 2 in the list. Okay. Now if I go to router 4, I will see 2 also as the neighbor. It is an init state. It is in an init state. Now it is in a two-way state. So DR BDR election is happening. So this is a DR other, that's why it is in two-way state. Alright. Now pinging from 5 to 1 or anywhere to anywhere is possible. Let me ping from 3. Ping 555:555:555:5. We are able to ping 111:111:111:1. Show IPv6 route OSPF. We have all this via OSPF. Administrative distance is same 110 as you have in IPv4, it's the same administrative distance, and this is the cost metric. So I hope you understood up to this level. Now let's get into BGP. BGP is very simple. If you know IPv4 BGP, it's same like that. Now I'm going to do BGP between R1 and R5. Alright, I'm going to do IBGP between R1 and R5. You know that for BGP there is no need of neighbor directly connected. There is no need to for the neighbor need to be directly connected, not necessary. So I'm going to go to router 5 and say router BGP. There is no IPv6 router. It's simply router BGP autonomous system 10. I'll say my neighbor is 1111:1111:1111. I'm using the loopback interface as the source. This neighbor belongs to remote autonomous system 10. This is not enough. You also need to say this. Address family IPv6 unicast, and then I need to say this neighbor and activate that neighbor. Activate. That's all. See how simple it is. Same like IPv4 you do. Using neighbor command, you type the IPv6 address and the remote AS. You go inside the address family of IPv6, meaning you are activating this neighbor under IPv6 unicast list. By default IPv4 is enabled, so you don't say address family for IPv4, but is because that is enabled by default. But for IPv6 it is not enabled, so you enable it by typing this command and getting inside that and saying activate. Now if I'll have a network, see I'm on R5. On R5 I'm going to have one more loopback interface. So I want to advertise that. If I want to advertise, I'll say advertise network 5555:5/128. I don't have this, but I'm going to have it now. You see, interface loopback 5 IPv6 address 5555:5/128. Now this is not advertised using Ospf. I'm advertising this one using BGP. So if R1 forms a neighbor with R5, I should see this network on R1. Let's check it. I'll go to R1 and enable BGP, router BGP 10. Neighbor is 5555:5555:5555:5. Remote AS is 10. Address family IPv6 unicast, same neighbor, activate. Now I'm expecting neighbor, but I tell you neighbor will not come up now. Why? I'm using loopback interface, so I should have said what? Update source command. Let us do that now. So before doing that, I want to show you the verification. Show IPv6 BGP, no IPv6 command. Show BGP for IPv6 unicast summary. You see, this is the neighbor that is configured. Command is different. Show BGP IPv6, but it is in idle state. It has not formed neighbor. The neighbor has never come up. So if I type the routing table, show IPv6 route BGP, I'm not learning that network which I advertised on R5. 5555:5. So let us use that update source command. Router BGP 10. Neighbor 5555:5 colon 5555 colon 5555 colon 5. Update source is loopback 0. See, the neighbor has come up, but it has to be done on the other side also for security reason. This neighbor is coming up because it is TCP session. If one side is given update source, then the other side will also work because of TCP connection oriented. But it is good to give on both sides. Router BGP 10 neighbor 1111 colon 1111 colon 1111 colon 1 update source loopback 0. Now if I go to R1, I can see show BGP IPv6 unicast summary. I can see the neighbor has already come up. There is one prefix learned from that neighbor. What prefix? Show IPv6 route BGP. This is that prefix. Because it is IBGP, it is 200 administrative distance. So hope you understood how to enable routing protocols on IPv6. Now one last thing I want to do. What is that? On R2, I'm going to remove Ospf. Or not necessary. I'll show you how to write a default route and static route. Okay, if you want to write a default route, this is the command: IPv6 route :/128. This means any network, any subnet mask. No. :0. Any network, any subnet mask. Send the traffic to the destination address. Let's say I want to send the traffic to router 3. So I'll say 2000. Anything you don't know, go to router 3. Assume, that's the gateway. Assume it is gateway. 2000 ABCD ::3. And what I'm going to do is on router 3, I'm going to have a network. Interface loopback, a new interface I'm creating, 33. IPv6 address 33 ::33 /128. Say I'm not advertising this on Ospf, but I'm trying to ping from R2. So according to R2, if it doesn't know anything, see, show IPv6 route. It says if something is not known, it will send it to this router 3 address. The default route is there. So if I ping now, I will be able to ping. Look at this. Though this address is not given by any routing protocol, I'm able to ping because of the static route, static default route. Now let's say on R4 interface loopback 44, I got an IP address, IPv6 address 1144 ::44 /128. So this is the network. I want to write a static route on R1. How to write? IPv6 route. Whenever you want to go to this address, go to router 4. What is router 4 address? 2000 ABCD ::4. Now if you ping, this address you will be pinging. So we have seen static route, we have seen default route, we have seen all routing protocols. Hope you understood how to enable routing protocols and static route and default route. If you have any doubt, you can ask me now.